Select the major products for the following substitution reaction. And so what we see here is we've got an alkyl halide and we've got some stereochemistry indicated, so we probably need to pay attention to that. And we've got methanol as our nucleophile, and we're looking at a substitution reaction. So we have two possible substitution pathways. The SM1 pathway, which is our stepwise substitution, and this tends to occur with tertiary alkyl halides. And the SN2 pathway, which is our concerted substitution. And this tends to take place with the less sterically hindered methyl, primary, and secondary alkyl halides. And so if we take a look at the starting material, this starting material is a tertiary alkyl halide. And that means that we're going to be looking at the SN1 pathway here. So if we want to draw a mechanism for an SN1 reaction, so we're starting off with this chiral alkyl bromide. And in the first step of this reaction, the bromide is going to leave, and that's going to form a carbocation. So there is the carbocation. So it's important to note that once you go from this tetrahedral carbon to your carbocation, it's now sp2 hybridized and trigonal planar. And that means that even though we started with a chiral substrate, we now have lost all chirality because that is flat around that center. And once we form that carbocation, this is the slow step of the mechanism, the nucleophile and the solvent, this methanol, will quickly react with that carbocation. And so we will form a bond between the oxygen and the carbon. Okay, and that oxygen still has a hydrogen and it still has a methyl group. So we have what looks like a protonated ether here. So to get to a neutral product, we're going to want to deprotonate. And this is a solvolysis reaction. We have a lot of that methanol around, so it can also act as a base and remove the proton. So there is another molecule of the methanol, and we can have it remove this proton to give the ether product. And since we had this sp2 trigonal planar intermediate, that means when we form our product, if it forms at a chiral center, we're going to see a racemic mixture. So that is an equal mixture of the R and then S enantiomers, as is shown in option D.